Hi, welcome. Again, my name is Jennifer Cedillo, and I'll be your instructor for yeast propagation, which is the second in this series in Module 5, and it will really address practical methods of yeast propagation in a brewery setting. Before viewing this video, I encourage you to read Chapter 5 in the yeast book, and then after viewing this video, review the exam materials that I give to you in the module before taking the final module exam. Further questions and information, please email me. Here's my email address. Also, we can have fruitful, useful discussions in the discussion board under Module 5, so please post questions there, and I'd love to address them for the whole classroom. In this video, we will discuss yeast propagation. Before we begin this discussion, I would like to point out a few essentials when considering whether to prop yeast in-house. Number 1, you need to have a laboratory established in your brewery before you decide to prop yeast. So, only after a lab is established should you consider in-house propagation. Secondly, sanitation procedures in your brewery must be a high priority. If you are not considering them a high priority right now, you should do so before deciding to proper grow yeast in-house. There are high upfront costs with in-house propagation, as some of the equipment and some infrastructure you need is pretty expensive. However, it will save money in the long run. A certain expertise is necessary in order to properly propagate yeast in-house. And this, when I'm talking about propagation, in this sense, I'm talking about from a plate or from a slant all the way up to the amount of yeast needed to pitch into your into 15 barrels or whatever batch you have. And then finally, the time devotion is high. So not only do you need someone who's has an expertise in the field, but they need to have time devoted to propping yeast, as it will take quite a few days and quite a bit of time each day to work on this. So if you do decide to propagate yeast in-house, let's talk about what is essential for yeast growth. And so I like to refer to the acronym FAT-TOM. FAT-TOM is an acronym taken from food safety, which tells food handlers the necessary nutrients needed for microorganism growth, but this can surely be applied to yeast growth as well. And so FAT-TOM, the acronym stands for food, acidity, temperature, time, oxygen, and moisture. And so we're going to go through each of these: food, acidity, temperature, time, and oxygen. Moisture, in our case, it's a given because we're working in a liquid media, which is wort. So I won't discuss moisture, but I will discuss the other 5. So when we're talking about what a yeast needs to grow and what you need to propagate yeast, you certainly need food for the yeast. The food for the yeast will be wort. It should be a 10 Plato or less wort, so a low gravity wort. It should include key nutrients. An example of that is zinc. Zinc is not present in wort, so you should always be adding zinc to the wort for the nutrients that the yeast needs in order to grow. Dry malt extract is a good source, preferably unhopped. So when you're growing just for propagation, just making up some dry malt extract, do not hop it, and you want it 10 Plato or less, and this can be a very good source of food for the yeast. When you're making this dry malt extract into actual extract, you need good quality water. I would recommend using reverse osmosis or distilled water. Preferably, especially if you're working in right off of a plate or in small amounts, the wort that you use should be sterilized. If this is not possible when you're working in larger amounts, then you should at least boil for 15 minutes to make sure that you kill most of the microorganisms that could be present. In addition to food, a proper acidity is needed for the yeast. Its ideal pH is 5. If you're using an all malt wort, or if you're using dry malt extract, the pH should be anywhere between 4 to 6, and this is okay. So acidity is not too much of an issue unless you're trying to use substrates or media other than all malt. Temperature is very important for the yeast. The recommended temperature for yeast growth is slightly higher than that of fermentation. A slightly higher temperature will allow the cells to grow faster. And so anywhere from 65 to 77 degrees Fahrenheit is what's recommended for yeast growth. And typically we use 68 degrees Fahrenheit for ale yeast growth. You can go as high as 98 degrees Fahrenheit for yeast growth, and it will certainly speed up the growth. However, you may be changing some characteristics of this yeast when you're doing it, and so that's something to keep in mind. The temperature will also depend on the yeast strain. So are you using an ale yeast strain, a lager yeast strain, or a wild yeast? Based on these different strains, there might be different recommendations for temperature, and so you should investigate that further. When you're talking about temperature, you're having this increase in temperature while you're growing the yeast, and typically in the last step of propagation, before fermentation, you'll reduce that temperature to that of fermentation, and this is especially important when using lager yeasts because they ferment at that colder temperature. Time is very important. So yeast need time to grow, and so basically you'll do your propagation, your step up, every 24 to 48 hours when the yeast is in log phase of growth. And so this is important to keep in mind this time and not let it go. If you let it go too long, they go into stationary phase and they start to die. If you go too short, then you're not allowing for complete growth and you'll have a reduced number of cells. So what is the time needed to grow up the yeast that you need? It depends on the temperature that you use, it depends on the number of steps that you're going to use, and it depends on your pitch rate, which we will discuss when we discuss yield factor. So oxygen is also extremely important. So when we're storing yeast, we're minimizing oxygen, and we don't want oxygen to be in contact with yeast. However, when you're growing yeast, you need oxygen. It's extremely important for its cellular respiration and for its reproduction and growth. Pure oxygen is best if you have it. If you don't, shaking, agitation, using a stir plate, or sterile air pump can all work, perhaps not as well, but still be adequate. Oxygen should be provided throughout the growth process. So whether you're using pure oxygen or some of these other methods, you need to be doing this continuously, not just once and done. The need for oxygen is very important in growth because it's needed for sterol and fatty acid production in yeast, and this allows them to be healthy and happy for your fermentation process. One thing that you want to avoid during your propagation is the Crabtree effect. The Crabtree effect is when ethanol is produced in the presence of oxygen. We can discuss that when we're talking about the actual propagation steps. So again, where will your initial source of yeast come from? You can purchase it from a quality vendor. You can have it stored on a slant, in a plate, or on a frozen stock. All of these are viable yeast sources. If you're going to use what's called a one-step propagation, you would purchase your yeast from a reputable source, and you would purchase it in liters. You would pitch 1 liter per barrel for the first step. You would let the wort ferment to 50 to 75%, so you check the gravity, and this will take approximately 48 hours. Then you add the fresh wort and allow the fermentation to occur. An example, if you have a 10-barrel system, is that you buy 1 liter of yeast, Pitch it into 1 barrel of wort. 48 hours later, you will add 9 barrels of wort to the initial barrel that you started with. This is a one-step propagation, and in the end, you'll make 10 barrels of beer. Yeast and Brewing Science Institute offer pitch rate calculators for one-step propagations that you can find online to make this very easy process. In addition to one-step propagations, you can do multi-step propagations. In multi-step propagations, the first half is done in a laboratory, and this can take 5 days to 2 weeks. If you're doing this, you should use only sterile materials, as you're starting with a very small amount of yeast, and any contamination can take over very quickly. The second half of this multi-step propagation would take place in the brew house. This can take anywhere from 5 to 15 days. During that time, you will start out at a higher temperature and lower the temperature of that to that of what you will use in fermentation. Things to keep in mind in the brew house is that the environment is no longer sterile as it can be in the lab. These are not ideal conditions. Also, oxygen is limiting. In the lab, we can supply oxygen throughout the process. In the brew house, this is not the same. This is not the case. So to give you an example of a stepped propagation, this is one taken from your yeast book. You can take a culture from a plate, as shown here. This is a petri dish with yeast growing on it. You take a colony from here, you place it into 10 milliliters of wort, which again is using the dry malt extract is sufficient. You let that go for 24 to 48 hours, and then about 24 hours, and then you take that 10 mLs and add it into 100 milliliters of wort. Again, you let that grow for 24 hours, and then you place that into 1 liter of wort. And so these are the type of flasks that you can use for that, and you can very easily use 10 ml. You can use a flask or a test tube, and then for 100 ml and 1 liter, you can use flasks, Erlenmeyer flasks. And then finally, from the 1 liter, you can either take this and go into the one-step propagation in the brew house, or you can use it in a 10 liter wort propagation step still in the laboratory. From the lab, you would take the 10 liter culture and then put that into 1 barrel. You would then take that 1 barrel and put that in and add 9 barrels of wort to make up to 10 barrels of a propagation. You can then add 50 barrels of wort, and this would be a 1 to 5 dilution, or a 5-fold step up. And then again, you can do 60 to 300, and then 300 to 900 barrels. These are very large amounts, and you would have a very big, large brewery if you're doing this. So typically in the brew house, you can do a 10-fold step up, which would be the 10 liters into the 1 barrel, 1 barrel into 10 barrels. These are all 10-fold step ups, where the 10 barrel to 60 barrel would be a 5-fold step up. This will take longer to make the same amount of yeast. However, the conditions are better for it, especially when you're getting into these large volumes, because the oxygen is so limiting. And you can see in the brew house, you have to keep in mind that you need vessels dedicated to this process. So from the lab, you can add 1 barrel to a fermenter that you can then add 9 barrels to. If you're going to step up beyond that, you would need another vessel to dedicate to the 60 barrels. And then also remember, during this process, wherever you're ending in the last steps, you should be reducing temperature to that of fermentation. The end result of any propagation should be a high number of cells, between 100 to 200 million cells per milliliter. Anything over this could be added stress on the yeast and is not necessarily considered healthy. Anything under this, they can be healthy, but you had some other limiting factors. They should have a high viability, more than 95%. If you have less than 95%, it could be that you're not you're not doing the step-ups at the right time because it's after log phase and some of the cells are dying. So you do want to see more than 95%. Also, you want a high vitality. And this is something that you should be able to measure if you are putting the investment into these multi-step propagations. You should be able to measure vitality in some way. Also, high glycogen levels are very important, and those should be there if you're adding enough oxygen and enough nutrients. And it should be free of contamination. Any contamination during the process will get magnified each time you step up, and so that can lead to high amounts of contamination at the end. So every brewery is different and has different needs as well as different facilities. And so when you're thinking about should you be doing propagation, you can think about it in whether you should be doing single step or multi-step. And basically anyone can do a one-step propagation, buying a small amount and doing a small propagation before fermenting out your beer is possible, even at the brew pub or microbrewery level that does not have a lab. If you want to do a multi-step propagation, you should have a lab in place. So again, even if you're a small production brewery, if you have no lab, it's recommended to do no propagation or just the one step. If you have a lab, then you can investigate methods for doing the multi-step propagation. Regional or macro breweries will usually have a well-equipped and well-staffed lab. For this, lab propagation and the brewery plant propagation is possible. So I'll just tell you some of the equipment that is necessary if you do decide to propagate in-house. If you do lab propagation, you need a whole set of microbiological media and utensils, including test tubes and flasks of various sizes. You need a way to stir and oxygenate your culture. And so these are just two examples here. This is a simple stir plate, which you can do up to 1 liter of wort on and propagate up to 1 liter of culture. And then here, this is a floor model water bath shaker. And so here you can do multiple flasks. Each one of these silver rings holds a flask, and you can have rings of different sizes hold different size flasks. So this is definitely more versatile. It does take more maintenance and is more costly, where this is relatively cheap. And this also will control your temperature because it's a water bath, and so it controls temperature and speed of the agitation. In addition to a way to aerate and agitate your culture, you need a pressure cooker or autoclave. Like I said, if you're doing lab propagation, the media needs to be sterile. Your equipment needs to be sterile. And that's because when you're working in such small amounts, it's very easy for contamination to take over. And so at a minimum, you need a way to sterilize, and you need a way to aerate and agitate your cultures. The Carlsberg flask is a great piece of equipment that can be used in between the lab and the brew house propagations if you're using a multi-step propagation. This Carlsberg flask is a complete system in that you can sterilize the wort within it, and it's a closed system, cool the wort down, and then use that same vessel for propagation. So it's a really handy use vessel, and you can do up to 25 liters. However, these are extremely expensive, and a 25 liter Carlsberg flask will run more than $10,000. In the brew house, if you're using propagation, you need a way to make smaller barrels of wort, whether that's brewing one of your other beers and taking 1 to 2 barrels of wort just for propagation, or is it on a pilot system or just using some other system where you can make 1 barrel of wort? You can do this again from dry malt extract, but you do need a way to at least boil it for at least 15 minutes in order to kill most of the microorganisms. You also need fermentation vessels, brinks, and or propagators within your brew house that are dedicated to this propagation. Also, before doing any propagation in the brew house, CIP procedures, having good CIP procedures, documented SOPs is extremely important. Any bad sanitation or bad cleaning of fermentation vessels when you're growing yeast and then pitching it can lead to major problems in the brewery, and so this is paramount. And then finally, there are industrial yeast propagation systems that are used in very large breweries. They can include, in this system, it includes a wort sterilizer, a propagator with a cooling jacket, a patchboard and controls, wort aeration pump and piping, as well as its own CIP station. So these are ideal for making clean and consistent yeast props. However, they are extremely costly. There are other considerations to take into consideration when you're growing and propping up yeast. Yield factor is one of them. Yield factor is described in your yeast book, and it's something that's used to compare your methods of propagation, how well you're doing at propagating your yeast. So the calculation is the million of cells per ml in the final culture, subtracted from the million of cells per ml in your initial culture, divided by the gravity decrease in Plato. And so this will tell you how efficient your propagation was. Factors that influence this are pitch rate and the number of steps. If you have a high pitch rate, your yield will be lower. If you have a low pitch rate, you could have a higher yield if it's not too low. If it's too low, then you may still see a low pitch rate. A low yield factor. The number of steps also can influence your yield factor and whether you're doing a 5-fold versus a 10-fold. Basically, a higher pitch rate will equal lower amount of growth, and this is typically what homebrewers do when they take home their, when they make a starter culture. They take a smack pack or a vial of yeast from a homebrew store and put it into wort and allow for a starter. Really, that's a very high pitch rate, so you're not getting a great amount of growth, but it's not harming the yeast either. You can be revitalizing it in a way, and you can get some growth out of it. It's just it won't be really efficient growth. A low pitch rate, if it's too low of a pitch rate, will equal beer and not growth. And so if you're not adding enough cells in the beginning culture, you'll just go through fermentation instead of respiration and growth. And so that's something to keep in mind. Something that's important during this process is to avoid mutations. The way that you can avoid mutations in your yeast is to use procedures that promote uniform growth. If you're using a procedure that promotes growth of a specific characteristic in your yeast, like you're putting it through high ethanol or low oxygen or some other environment, you could be selectively growing yeast with mutations. You want to also avoid the overuse of yeast, not using yeast for too many different procedures. And so always going back to a central culture that will not have the mutations present. You also want to avoid stress of yeast during growth. If you stress out the yeast during growth, it won't be healthy and happy for your fermentation, and you can be producing mutations. Finally, you want to minimize contamination, and so you do this through using sterile equipment and media when possible. If you can't use sterile equipment and media, sanitation is paramount. Use the aseptic technique, which we will discuss in Module 9, and also practice good sanitation. And just on an ending note, sanitation is vital. If you do not have good sanitation practices, you should not attempt propagating yeast. Please get your SOPs down for sanitation and make sure that your cleaning procedures that are in place are effective before starting yeast propagation. Here are the resources that I've used for this lecture. I encourage you to go through them and do some more research on your own, and please feel free to email me or post questions on the discussion board. Thank you.